Okay, so we're going to start Chapter 10, Reaction Rates and Chemical Equilibrium, by going back and looking at Chapter 7.9. This is one that we skipped earlier, but now we need to know about the energy in chemical reactions. This is back in your book on these pages. These are two plots. The y-axis is going to be energy, and the x-axis is going to be the direction of the reaction. Okay, so when we start a reaction, our reactants have a certain amount of energy. That's our reactants, and our products have a certain amount of energy. Better if I could draw straight lines, but that's okay. And during the reaction, the amount of energy changes. We know that energy is not created or destroyed, and so for the reactants here to make the products here, there must be energy absorbed. And this is an endothermic reaction. I'm going to change colors just because endothermic is such an important word. Endothermic. I want you to think of this as in. Endo is in, so energy is going into the reaction. Endothermic reactions feel cold because they are absorbing heat energy from the environment. The other possibility is that we could have reactants that have this amount of energy and products that have less energy. And we connect these. We see that energy is released. And this, we'll change colors again, is an exothermic reaction. And it's going to feel warm. It's going to give off heat. So a fire, a wood-burning fire, would be an exothermic reaction. So conservation of energy tells us that energy is not gained or lost. It's only transferred. Endothermic reactions, that's the green one here. Let's change to green to do that one. The reactants have less energy. And energy has to be added. Energy is absorbed. Exothermic reactions, the reactants have more energy. R's for reactants have more energy. And energy is released. We have this energy, we have a symbol for it. We call it H, enthalpy. And the change, we can go up here so we can see this. The change here is called the delta H. And because energy is being absorbed, delta H is positive for an endothermic reaction. And because it's released, delta H is negative for an exothermic reaction. So here we have our summary slide. A little bit of summary here. Energy, if we have an exothermic reaction, energy is released, feels warm. Heat is considered a product. The reaction makes heat, just in the same way that it makes any other product. The sign of the delta H is negative, and the energy of the reactants is higher. Energy reactants higher. Okay, endothermic reactions. Energy is absorbed. And these reactions feel cold. And as you might guess, there are fewer endothermic reactions than exothermic reactions. Heat is considered a reactant. It goes into the reaction. The delta H is positive, and the energy of the products is higher. And that's all for this chapter.